good evening, good morning, good afternoon, depending on whichever area we've been. We're going to be watching the class from, and this is Networking's IT solution. We've been looking at the fundamentals of networking, and our major topic has been looking at the difference between the classful and classless IP subnetting. So we look at the classful IP subnetting in the first class, and this class is going to be the second of this series, and we're still going to have a third of this series because we're going to have to do some calculation, doing subnetting, and the rest. But then we need to understand what classless IP. How does it come about? What do we really mean when we say classful and classless IP subnetting? So that leads us to today's class. We said IP addresses and subnets are necessary for effective network communications. In this class, we're going to be learning more about how IP addresses and subnet works and how to compare classful and classless IP addresses and more about subnetting. Now, if you have a question, you can just drop it on the chat box, and I'll also stop intermittently to ask us one or two things and also get feedbacks. So we've said this over and over again that the means through which network devices communicate on a network, either LAN, WAN, MAN, irrespective of the type of network it is through IP address. Network devices use IP addresses and subnets to identify the source and the destination of communications and manage network addresses respectively. So in the last class, we explained something very crucial about IP addresses containing two parts. We said it contains the network identifier and a host identifier. I will explain that. So a network identifier and a host identifier. We said that if we see an IP, there is a portion that we call the network portion, and there is another portion we call the host portion. And what helps us to distinguish or differentiate between these two uh, kind portions of the IP is the I want to explain something, so I'm trying to clear up this. Just look here now. So if I have an IP 192.168, for instance, does 220.10, for instance, and we said that is a /24 IP. In our classful subnet, in classful, we know that since it's /24, the subnet mask will be 255.255.255.0. So this first 3255 is the network portion. Please confirm to me on the chat box that you can hear me and that you get what I'm talking about. Now, so 192.168.20 192.168.20 is the network portion of this IP, and .10 is the host portion. So .10 is going to be the IP sitting on the device. So this is the host portion or host ID .10. Why 255, this 192.168.
I can't see your screen, Sal.
Okay, if you can't see my screen, I think it has to be maybe from your network. Madam Esther, can you see my screen, please? Uh, one of the one of us had already confirmed that he can see my screen. And I also joined with my another device and I can see my screen from that device. So you might just have to log out and log in again. Okay. So like I was explaining, 192.168.20 is the network portion. So let me type it here. 192.168.20 is the network network portion or network ID. Y.10 host ID. And how do I know this? I know this through the subnet marks. We will get more detail in this as time permits us. So I come back now to explain this again. We said network devices use IP addresses and subnets to define the source and destination of communication and manage network addresses respectively. IP addresses contains two parts, the network identifier and a host identifier. Those are the two parts of an IP address. The network identifier specifies an area of the network where a device resides, much like an area code identifies a section of a telephone network. The host ID labels a specific device in that network. Like I was saying, I said dot 10 in this case now is sitting on a particular device. The same way we can have dot 11, dot 12 sitting on another device, dot 13. But in this kind of network, for instance, you can never have anything outside of 192.168.20. Everything resides within. This is the network block. All right. Like how a telephone number identifies a specific country. Now, we try to explain this. You see, sometimes when we receive call from outside the country, we quickly identify which country that person is calling from. For instance, if you see +44, it is a call from United Kingdom, UK. Now, Nigeria call code is +234. For Afghanistan, +93, on so many on. So with those code, you already know the country the call is coming from. The same way, the network ID is talking about the country the call is coming from. But after you have seen 234, you will now see another number, which is now the number of the person calling. We could still go further by saying that, okay, apart from the person calling now, we could say, okay, what provider is he calling from? Is he using MTN? Is he using Airtel? Is he using a Etisalat? So these are way we can explain network and host. Most business network still rely on IPv4. We call it IP version 4 addresses, which offer about 4.3 billion unique variations of IP. 4.3 billion. However, we know the number of people in the whole world. Imagine all devices are going to be needing a public IP. It will not be enough. But there is a technology that has been designed called NAT. I've explained this to us before, but we'll still look at it when we start doing some configuration. NAT, Network Address Translation. This is what enables us to be able to map numerous many private IP to one public or multiple public IPs for the purpose of having internet access. But the newer IP version 6 standard provides more addresses and other benefits. We've looked at all of this before, but I want to just quickly go to the class today, but we need to lay this foundation for us to be able to understand where we're going. Computer works with IPv4 addresses as a 32-bit binary string. I've explained this to us before, that the 192.168 we are looking at here is actually written in this 192.168 20.10. The computer does not understand this. What computer understands is 111.0.111 in 8 places. It's an 8-bit dot 1111. This is the way the computer can understand whatever it is this IP is talking about. So that is where we said it's a 32-bit binary string. Human usually convert binary to a doctored decimal address. That's why we are saying that 192. And I've explained to us how we convert, for instance, if we are to convert our 192.168.20.10 now to binary. I showed us that the last time. I think, which one was I sharing? Okay, it was okay. So in the last class, I was sharing with us this. So 192 is, when we converted 192, we saw it as 11.000.11.000.000. So this 192 now is 11, then 00 in 6 places. So that's our 192. So let's check what is 196. We'll do that, and then 196, we said we'll divide by 2. So how many 2 can we say in 168? In 16 is 8. In 8 is 4. Then remainder remains 0. Next, in 84, 4 and 2 remains 0. In 42, we have 21 remains 0. In 21, it's going to be 10 remains 1. In 10, it's going to be 5 remains 0. In 5, it's going to be 2 remains 1. In 2, it's going to be 1 remains 0. And in 1, it's going to remain 0. We bring that one out. So in other words, and we are to take our writing upwards. So it's going to be 168 equals to 10101000 in base 2. So this will be the binary version of 168. Do we understand what we are doing here, please? So we'll do for 20 now. So to understand for 20, 2 in 20, we go 10, remains 0. 2 in 10 will be 5, remains 0. 2 in 5 will be 2, remains 1. 2 in 2 is 1, remains 0. And then 2 in 1 is 0. Remove the 1 front, so we have 1. So in other words, 20 in base 10 ordinary equals to 1, 0, 1, 0, 0. Now, the question now is going to be, oh, it's supposed to be 8 bits, but this is 5. How do I know where to complete the zeros? That's going to be our next line of action. So, but for you to be able to solve the problem and know which one will be the solution, I always want to do a check. So if I do, this is raised to power 0, 1, 2, 3, 4. So 4 raised to 2 raised to power 4 is 8. So where the 0 will be behind 1, 2, 3. So how many do we have before? 1, 2, 3, 4, then 4. So this will be 0. You complete it from behind. So for me to know which place my values works from, I'll say sorry, 5. Then this will be 0, 0, 0. Complete it. So this will be 0 raised to power 0, 0 raised to power 1, and 0 raised to power 2 here. Or sorry, 1 raised to power 2. That's going to be 0 times 2 raised to power 8 or 7 raised to power 7 plus 0 times 2 raised to power 6 plus 0 times 2 raised to power 5. So we already know that all of this, anything multiplied by 0 is already 0. So the next one we are concerned with is the first one, which the first one we are having there. That's 1 times 2 raised to power 4. Raised to power 4. The second one is 0, which is going to be raised to power 3. And the third one is going to be, the next one is going to be 2. 1 times 2 raised to power 2. So 2 raised to power 4 is 2 times 2, 4. 4 times 2, 8. 8 times 2 equals to 16. Then plus 1 times 2 raised to power 2, that's 4. 2 times 2, 4. That's how we are able to get 20. So the zeros will be added to the front. That's to the left when you've done the conversion to binary. So it's going to be added to the left hand side. So our answer is this, but then we added the 3 0 to the front. So this is our dot 20 in binary. So 10, which is the host, so we want to convert 10 to binary now. So we say 2 goes in 10, that gives us 5, remainder 0. 2 goes in 5 is 2, remainder 1. 2 go in 2, 2 go in 2 is 1, remainder 0. And 2 go in 1 is 0, remainder 1. So the same way, 10 now will be equals to 1, 0, 1, 0. However, we add the remaining 0 to the front. So it's going to be 0, 0, 0, 0, then 1, 0, 1, 0. So this is going to be the binary format for the dot 10. So this is the binary format. This is the format that the computer will understand as this IP. So 192.168.20.10 is equivalent to this. Do we understand what we are saying here? Hello? All right. Thank you. So human usually convert binary to a dotted decimal address, which is easier to understand, to write and to understand. For example, the binary string 11000000. So this now, it's telling us, we could see now that, for instance, we look at 11000, you will see that it's equivalent to the solution we have here, 110000. So then 1.0 is going to be zeros in 8 places. Then 2 will be 10, but you now add the remaining 60 to the front. If you look at 2 here, we can go back and quickly do 2. So if we say let's convert 2 to binary, so 2 go in 2 is going to be 1, remainder 0, and then 2 go in 1 is going to be 0, remainder 1. And if we are to move it up, so our answer will be 2 equals to 10. That's 10. However, we need to make it 8 bits. 8 bits in an octet. So that 8 bits now will be comprising of 6 zeros in front. 60 and then the 10, which is either a on and a off. So that's how we got these two, and the same for these two. And its associated subnet mask converts from, now look at this subnet mask. This is /30 subnet mask. /30 255 255 255.252. When you see everything is 1 all through, it is 255. If we convert 255 to binary, what it will give us is this 11111 all through. Maybe we should try that so that we can understand what I am talking about, so that nothing should scare us when we see an IP address. So we say 2 and we want to convert 255. So how many 2 can we see in 255? In the first 2 is 1. In the 5, you see 2, remainder 1. In 15 is 7. So it's going to remain 1. Then 2 again in 127. 2 goes in 12 is 6. 2 goes in 7 is 3. Remainder remain 1 as well. 2 go in 63. In 6 is 3 times, and in 3 is 1, remainder 1. 2 go in 31. In 3 is 1, remainder 1. In 11, it's 5, remainder 1. 2 go in 15 is 7, remainder 1. 2 go in 7 is 3, remainder 1. 2 go in 3 is 1, remainder 1. 2 go in 1 is 0. We move the 1 out. So you can see that 255 is equals to 1, 1, 1, 1, 1, 1, 1, 1. 1 in 8 places. So that's how we got 255, 255, 255, and 252, which is the last one. You could see that that has changed to 111 in 6 places plus additional. So if you convert 252 to binary, it will give you this. We're going to have an assignment at the end of this class to go home with. So, subnet mask clarify which part of the address is the network address or network ID and which is the host ID. I had already explained that it is the subnet mask that help us to know which part is the network and which part is the host. We can move forward. Routers, computers, and network troubleshooters use IP address and subnet masks to manage network traffic, which ensures information sent from one system arrives at its destination. That is the major factor. Because why do we need a network? For the purpose of exchanging information, for transmission of information. IP address fundamentals. Please, this is very important. Network devices typically have the following 3 identities, which includes number 1, physical address. When you hear the word physical address, is the MAC address, media access control, the MAC address of a device. Every device has a unique MAC address. Then we have what we call the logical address. They can ask you this question in an interview. What is the difference between a MAC address and a logical address? Your logical address is the same thing as your IP address. Your physical address is the MAC address that comes with the device from the OEM. Most of the time, your MAC address operates in layer 2. IP address operates in layer 3. Then host name, useful for humans to recognize the device on a network. So your host name, I think I have a slide. Okay, look at this. IP address of a workstation. So you see the host name, we call it dev workstation 01. That means we might have different workstations on that infrastructure or on that land. And so we could have dev workstation 01, dev workstation 02, dev workstation 03. Excuse me. So we say IP address. You could see the IP address here 192.0.2.10. And we could see the MAC address. This is the way the MAC address always looks like. In the case of IPv4 address, each host has a unique IP address on the network and nodes relies on it to exchange information. I must know the IP of your system for me to be able to send documents to you. I must know the IP of my printer in order to be able to print on that printer. Data breaks down into pieces known as packets, which then travels across the network. Each packet contains a source and destination IP address. Just like when you want in a post office, there must be the address where you are posting the letter to, and the address it's coming from. So every information, every packet, every data contains what we call the source. As a matter of fact, we have the source MAC address, the source IP address, then you have the destination IP address and the destination MAC address. Okay, you can look at it from here. So we have the Ethernet header, we have the destination IP address, and we have the source IP address. This is the way an IP packet looks. So we are trying to compare and contrast with a mail or a letter you are sending. So the letter is coming from Alice, who lives in 789 First Street, Other Town, ST 5C789, and is sending it to Bob. So Bob here is the destination. Alice here is the source. It's coming from Alice, source, the person sending the packet. Bob is the receiver, the destination. Don't worry, as time goes on, we're going to be looking at what payload is and what CRC, what it means. Network administrators can subdivide networks into smaller, more manageable sections. This process let them control the flow of network traffic, isolate traffic to increase security, and limit traffic to certain areas of the network to improve performance. So why do we really need subnetting, or what brought about classless IP addressing or IP subnetting? These network segments are called subnetworks or subnets. Each subnet has a unique identifier within the larger network ID. When administrators divide a network into parts such as engineering and finance, in a company you could have IT department, finance department, engineering, HR, and so on and so forth. The address structure is based on numbers. So I look at this slide. Subnetworks for different departments. So in this one now, we are seeing a router. We could see engineering subnet IP there is 192.0.3.0, but you could see the finance subnet address is 192.0.4.0. So in this case now, if you are dealing with a class full subnet, this is obviously going to be a /16, whereby you can only make modification on the last two octets. You can only make modification on the per octet, not inside of the octet. We'll still explain that. So we know we've talked about public IP address and private IP address range. So systems and sites on the public internet consume most of the roughly 4.3 billion available IPv4 addresses. So we are saying systems and sites on the public internet. So those are the systems that want to access internet directly. But sometimes we don't want our system to access internet directly. We just want to set up a LAN. Remember, LAN, local area network. Just be able to talk within your office. You don't want to access the internet. So those devices still need IP address. That is where the need for private IP comes in. However, private network can reserve some ranges for internal use. Networks in home offices and businesses likely use one of these range. The next slide defines private range IP address. So this is it. If you look at your phone or your system that you are browsing with, for instance, your IP is going to be within this range of IP, either 10.0.0.0 range, which is class A, 172.16.0.0, which is class B, or 192.16.0.0, which is class C. Now, if I do, just sharing something now, if I do IP config, you see my IP now, 192.168.84. So I am within this range, class C, smaller networks with fewer hosts. Remember class B, medium network with a moderate number of hosts. But these classes, when you have not done any subnetting on them, you can see larger networks with many hosts. All right. I explained all of this in the last class. You could visit that again. So let's look at what is the difference between subnet and subnet mask. They are different. When you hear the word subnet, it's a different thing from subnet mask. Now, when I showed you my IP here a few minutes ago, this is my IP address, but this is my subnet mask. Now, however, we want to explain subnet first. Subnet are an isolated network segment, which is a piece of the network that an administrator divides off. Aha. Network administrator typically creates subnets for the following reason. I will explain. Why do we create subnets? Number one, for security purpose. Number two, for performance. So subnet isolates traffic for privacy. You will see in the next slide. Performance. Subnet manage traffic to reduce network congestion. You know, subnet created for security purpose prevents specific traffic type from traversing the rest of the network, where they could be vulnerable to interception. So let me go back to the slide where I was explaining something here. So imagine if, for instance, let me use here, give me a minute. Sorry. Okay. So if this IP 192.168.0.0/16 has been allocated for a network, for instance, for a LAN. Now, and you have HR department, you have finance department, you have IT department, you have what other department could we have? We have engineering. Let's just make use of these four. Now, since you can play with these two octets, because /16 means you are having /16 means you are having 255.255.0.0. So you can choose now to play with all these. So you can make your HR department to be 192.168.10.0/24. Make your finance to be 192.168.20.0/24. The next one, IT 192.168.30/24, and so on and so forth. This will help you. So it becomes impossible for HR to be able to reach finance traffic, even though they are on the same network. But with this subnetting, it becomes impossible for HR to be able to reach finance. So that is what we call for security. Also for performance, subnet manage traffic to reduce network congestion. So for instance, if HR people are sending a whole lot of file, their file is going to be congesting on just this IP range, not on the finance. Finance will still be having, seamless uh, thing on their own network. So we said it isolates all computers in the finance department to a single subnet, which effectively prevents finance network from communication from moving across the entire network. So we look at this design the other time. We said finance IP is 4.0, while engineering is 3.0 here. So it's if the engineering is going to reach the finance, a router has to be integrated or a layer 3 switch. All right. Subnets for performance decrease competition for network access on congested network. I've explained this. If an organization's engineering department regularly transfer files that affect network performance for other users, network administrator can isolate the engineers to their own subnets, which reduce the effect of their file transfer on the other users. Network administrators often define multiple subnets for both security and performance reasons. So that's what you need to pay attention to. Why do we define multiple subnets? Number one, for security purpose, to ensure that finance traffic are kept in finance subnet. Engineering traffic are kept to engineering subnet. IT traffic remains in IT subnet or guest users. And so these are things. So you don't expect that you put your guests, people who comes to the office, just you don't even know the kind of device they are bringing to your company. All of a sudden you connect them to the corporate Wi-Fi. No, you should have a guest Wi-Fi whereby that does not have access to the corporate network. Okay. That is the work of network administrator. So, what is subnet mask? That is what subnet is. Subnet is when you create different subnets of an existing network. But I've explained what subnet mask is for us, and I explained even at the beginning of the class that subnet mask, on the other hand, plays a different role. Network devices use the subnet mask to determine which part of a host IP address is the network ID and which part is the host ID. Subnet masks are relatively used with IP addresses. Essentially, subnets are an area of the network, while subnet masks help devices determine the network to which they belong. So, for instance, 255.255.255.0 is a /24 subnet. So thank you. So like I was saying, the subnet mask is what helps us to determine the network ID and the host ID. So for instance, in 255.255.255.0 is a /24 subnet mask. So the first three is the network ID and this is the host ID. We've already explained this part before. So let's quickly move on and see how far we can go. So IP address classes. IPv4 address device into 5 classes. We've explained this before. The primary difference between the first 3 classes, class A, B, C, is the number of subnets versus the number of hosts per subnet. The next slide clarify this. So if you look at this now, class A, the first octet is 1 to 126. Number of subnets is 126, approximately 16.7 million. Many hosts per network. Many hosts. So if we are saying class A, for instance, now this is what it's saying. In class A, class A is 255.0.0.0. So the network is just this. Why this is the host? All these three is allocated for the host. So that is why we are able to have 16.7 million many hosts. So it's used for larger network. Class B is between 128 to 191. And I said 127 is reserved for loop back. So number of subnets 16,384, and the number of hosts is 65,536. Many hosts per network. Then class C, which is mostly used, 192 to 223, approximately 2.1 million subnets. And how many hosts? Just 254. Many network with fewer hosts per network. So class D addresses are for a specific type of communication known as multicasting, which lets a host transmit thousands of data streams to other devices. Class E is also used with standard IPv4 networking. Instead, IP address researchers use Class E addresses for experimental and developmental purpose. Let's move on. This classification system is known as classful. We've defined that. So classful addressing relies on rigid division between the network ID and host ID. So what we are saying is this division always occurs at the 8th, 16th, or 24th bit in the address, which are, so we look at this 255. This first one is the 8th, this first one, then /8, then 255 this is /16, then 255 which is /24 for classful. So it remains here. You can't make any modification here in classful subnetting. This design often wastes IP addresses. That's true. However, for example, class B networks provide 65,000 host ID, and class C network offers only 254 host ID. If a network has 2,000 devices and administrators select, we have to select class B because class C cannot work for you. They would waste, when you remove the 2,000 from the 65,000, you will now have 63,000 addresses still wasted. And this is why classless IP addressing came into existence. So the reason we bring, or the emergence of classless IP addressing, is so that we can minimize, we can maximize our IP addresses and do not waste them. So this is where we will start the class tomorrow. Classless IP addressing. But I'm going to give us an assignment. So thank you for coming to class today, and do have a wonderful night's rest. Do we have any question, please? Does anyone have any question? Hello? Are we still here? So we're going to be looking at classless IP addressing, often called classless interdomain routing, tomorrow, same time, 8 p.m. Thank you, and do have a wonderful night.